Alright, dudes. I'm almost finished, but what I'll do is I'll put up fake EJ for a second, and we'll start jetting into the space news. Let me switch this over to just chatting, and then we switch the directory back to science and technology. Rocket under construction in the UK. Ha! Nice, man. Can you show me a taquito? Taquito, it's Spanish for mini taco. It's just a tortilla roll with cheese and chicken in it, dude. That's it. Have I missed SpaceX news? I actually was gonna dive us right into a Starship video coming from NSF, and I'm gonna mute it here, and I'm gonna finish eating. We also have mozzarella balls. There's big cheesy balls. Cool. Watch this. I'll be right back. Oh, hi Tom. How are you? Everything good? All right. Looks like they're moving SN15 into the high bay right there. This video is actually a little outdated. SN15 has already been stacked, and we're looking at a rollout to the pad, possibly on the 5th. Yeah, pretty cool. Entropy. Alright. Switch off the auto streamer. EJ, you switched off the auto streamer. What's wrong? Nothing. I'm alright. All right. So yeah, this is footage from yesterday. They put SN15 together. I mean, it's gonna take a couple of days before they get it checked out, but Hey, Funkmaster. What's going on? The auto streamer? Gained a little bit of weight, it seems. Are the flaps shaped different? No. Ah, yes. The very famous Toyota crane. Yes, Toyota. What am I going to do? A submission for Deer Moon? I don't know. Toyota is little known Russian brand, yep. It's past the deadline? Yeah. Nice, Audrey. There you go. No brand, no Deer Moon. Yeah, it definitely is gaff tape right there. No, Linprod. Yeah. Huh. I like how they just bolt scaffolding to the side of the dang thing. What kind of wood is that? It just looks like pine. Oh, hey, guy. Oh, hey, buddy. Any running theories on the SN11 run? Something caused a catastrophic explosion. Honestly, something with SN11 caused a massive explosion in the back. It was enough to rupture the pressure vessels, possibly even trigger the flight termination system. I don't know. People seem to be very antsy in their pantsy about that or not. Whatever happened, it was some kind of ridiculous rud. Not ideal. Now, because the thing was so... It was in the fog. You couldn't see it. We couldn't see it. We couldn't see the dang thing. Just so you know, did I miss Space News? No. I'm going to own you at it. Could it have anything to do with the helium? Well, helium's inert, Maplish. It really doesn't explode. Quit smoking. Favorite stream. Hope EJ and Chad is having a great weekend. I just landed a new position and you're feeling good. Congratulations, aliens. No, Audrey, it was the electric eye. Burn now, 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 burn now, 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 burn now, now, now. I'm electric, electric eye. That's a great song. Confected, electric eye. Anyway, never heard of them? Judas Priest? The Hellion Electric Eye? That's a great song. It's about spy satellites. I am professional. I keep the country clean. I'm electric eye. Is there AC tonight or is that on Fridays? It's Fridays. Yeah, yep. Scott Manley in his video said sources say that it wasn't in a flight termination system. As much I would like it to be a flight termination system. Swishio, honestly, it doesn't really matter to me anymore. Okay, so who gives a crap what exploded? I want to know what triggered it because, okay, if the engine seriously malfunctioned and caused an explosion, the flight termination system would trigger anyway. So it really doesn't matter if the FTS blew it up or if an engine blew it up and then the FTS triggered. It doesn't, like I was turning this in the other day. Everybody seems to be about, oh, did the FTS trigger? Did the FTS not trigger? That, you know what, dude? That doesn't matter. It really doesn't matter. And I'm not trying to say that like, oh, no, it's not. Something happened with a reignition that either A, caused the FTS to go off, or B, caused the vehicle to completely disassemble itself. You need an insane amount of pressure to just create stainless steel shrapnel, I guess. Because rocket tanks like to unwind, right? Like, okay. Here, let me show you, like, look at SN9's landing, okay? SN9's a really good example. The tanks, like, delaminate. They just basically peel apart. It looks like what happens if you stuck a knife into, like, a soda can and then you started ripping it apart. It tears, right? That's what it does. All right, so here, let's check it out. So, like, watch the tanks. Like, this is hitting the ground going at some speed, right? So, I mean, this is an impact, right? And look, see the tanks delaminate right there? They just kind of, it's like, once again, it's like ripping a soda can open, right? I mean, these, funny thing is, a soda can and that thing aren't that far off. But with 11 guys, we saw a massive explosion, enough to fragment the entire back end of Starship to the point where there's one or two recognizable pieces. You need to have an insane amount of energy build up somewhere in the system to do that. All right, they're like propellant getting stuck in the lines, or like an overpressurized tank is really all I can think of. So somewhere in the system in the plumbing it overpressurized. I don't know if that's to like. If it's like, I don't know, did a LOX tank overpressurize? Did a plumbing line inside of a LOX tank overpressurize? There's not really any, this is the part where it gets really sketchy, and this is why I don't think it's kind of stupid to argue over it or like have a debate about it. Like, it doesn't matter if the FTS caused the problem, or if the engine's something overpressurized. Either way, if the FTS was or wasn't triggered, something went massively wrong with that thing. Like, massively wrong. Now, what's that? Huh. Forge, Brimo and I saw something fly overhead. We saw, I think we saw the X-37, if I had to guess. What's the inclination on the X-37's orbit? I think it's USA 240 something. I saw it. We definitely saw a spacecraft fly over the other night. It flew past, like we were looking at the moon and I saw it go by. You're being illogical. It was the ULA sniper. Floating, that's the thing, man. Even it was not the ISS, Lenprod. The ISS was over Africa because it was a spacecraft. Because the first thing I thought is I was like, oh, we saw the ISS. It was not the ISS. We saw something up there. It could have been a spacecraft. It definitely was in a lower orbit, somewhere around 400 to 500 kilometers, because it looked exactly like the ISS. So it was at ISS altitude, and it was going northeast, so 45 to 50 degrees inclined, somewhere around there. Yeah, Astrain, the first thing I did was check my phone. I'm like, oh man, that might be the ISS or a Starlink satellite. And it was the proper inclination for a Starlink satellite, and also the ISS. The ISS is 51.6 degrees inclined. Starlink satellites are 54 degrees inclined. So it was the right track, but there was nothing behind it. There was no Starlink train. I waited for another couple of minutes. No satellites came over. 44.6 for the X-37. I think we saw it. I think we saw the X-37, dude. I'm pretty dang sure we did, actually. 44.6. Yeah, like I said, the track was, it was like 45 to 50 the way it was going. I should have gotten my compass out and checked. It's Hermes, yeah, right? How can you tell a spacecraft from a satellite? It's closer. Thrawn, literally, it's closer. Really easy to see a craft in low Earth orbit when you know what to look for. I know what to look for. I've seen Starlink satellites. I've seen the Starlink train at 500 kilometers. This was closer than that. This was an orbit 300 to 400 kilometers, somewhere around there. Could have been Zuma. What's the X-37? The Air Force has something like DART, Reagan. Yeah, the X-37B. Have you never seen this thing before? Dude, X-37Bs are sick. They're so cool. I really wish we knew, like, or we had, like, access to this tech. Russian inspecting spacecraft. I mean, PY, it could have been a Cosmos. I don't know. The X-37 is like what happens if we tried to make Shuttle Mark II. And this thing exists. There's a picture of it, dude. So the X-37 is a space shuttle that has, it's a little mini shuttle. And it has a payload bay that's, I don't know, it's about the size of a long bed pickup truck. So like maybe 8 feet. 8 feet by like 6 feet. And it has a deployable solar panel inside of the payload bay. The solar panel actually folds up and out to the side. So that thing can just stay up there. The X-37 has been up there for over a year. These things are designed to stay up there and do whatever. It's a Space Force ship. I mean, it's funny because the one up there still says USAF on it right now. It uses hypergolic thrusters, and hypergolic orbiter maneuvering systems. Other than that, we don't know what it does. It's part of the Air Force's rapid deployment program, so it's prototyping something. It's prototyping, my guess is some kind of satellite optics or whatever, but this thing can do all kinds of crazy things. And it has downmass capability. The Air Force has been flying these for a little while. They're really freaking cool, actually. Yeah, it uses Tough Rock, the same tiles as Starship. Or I should say, Starship uses the same tiles as the X-37. The X-37 is made by Boeing, and it's, the Tough Rock tiles. These are the same tiles that Starship is going to use. The X-37B's nose cone is not reinforced carbon-carbon. It's just tiles. The tiles straight up resist the hypersonic shock. See? Check that out. An all-tile heat shield. That's ridiculous. No RCC on the leading edges. Nothing. So you don't have to worry as much about debris strikes. I mean, that's not going to happen, but... Yeah, Reagan. What's the size of the payload bay and what's the size of the Russian communication satellites? The Cosmos satellites are way bigger than this. See last please. Some sat watchers got it in 2019. Yeah, it was... Okay, Forge, and keep in mind, amateur astronomer. I'd have to talk to Greg about this. It was a 400 to 500 kilometer orbit, and people are gonna be like, "How did you know?" Like, I can just tell because I've seen the ISS go by a couple of times, and that's 400. It was 400 to 500 because it was big. It was bigger than the satellites. You could see the satellites out in geo, and if the weather's not in geo, those are too far away. You could see Molina orbits if you know where to look. Lightning orbits, which. I mean, I suppose you can kind of see them. But only when they're close to Earth. Either way, this thing was in a low Earth orbit. It was definitely LEO. Definitely 45 to 50 degrees inclined. And it definitely was not a satellite. It was not the ISS. I know it wasn't the ISS. Because, honestly, if you squint or use a telescope and look, you could see the solar arrays. So yeah, I saw it. It definitely was something. Like it was a spacecraft. I know it was a spacecraft. I know it wasn't a satellite. Don't ask me how I can tell. Like it's just one of those things. I've seen Dragon flying behind the ISS. It looked like that. Yeah, you could see the spacecrafts following the ISS if they're in on a docking approach and it crosses over you at the right time. You can see them. How can you tell it wasn't the ISS? I looked at my phone, Jado. You can here. Hold on, just in case like Google Maps pops up and says, "Hey, the ISS is not near you." Here. Yeah, I know. I was kidding. Were you though? Do they have weapons for these? No, no weapons. I'm guessing so. It was testing a Hall effect thruster, which is pretty cool. On one of the last X-37 missions, the Air Force actually declassified the mission after it was done. They tested an ion thruster. They tested some SEP. Dude, that thing was maneuvering around with an ion thruster, which is cool. And what's crazier is that the ion thruster, from what I understand, and this is cool, you can talk about it. It's not like people are gonna come to my house, knock on the door. I mean, I don't know, they might. No, no, it's a declassified mission. I know that, and I wouldn't talk about it if it wasn't. They were maneuvering it around with the ion thruster in the payload bay. So like the thing was flying like this. See, lads, please, and don't worry. Yeah, see, it was released by Boeing. Dude, I mean, X-37s are cool, man. I really wish Boeing made a crew version of it, but. All right, let's check. Look at this. Look at this. Dude. So. Dude, I'm telling you, this is just a Mark II space shuttle. If they were going to build Shuttle Mark II, this is exactly what it would look like. Switchio, this is one piece of equipment, dude. Totally reusable. Comes right back down. So the tails are out there, and they're dihedral out. They're dihedral out like that to get the tail into the plasma flow. That's a big deal. That was one of the problems with the space shuttle. Demo was actually telling me about this yesterday when I was building this. So the shuttle would have been better if it had a tail going out like this and a tail going out like that. Because check this out, and I'm going to use this as a model to teach people. When the shuttle's coming in like this, the shuttle hits the atmosphere at a 40-degree angle, like this, and basically turns the entire bottom of it into a huge air brake to slow itself down, right? Right? When you're flying like this thing is being occluded. All the air and all the plasma and the plasma shock is being shot out here. This thing isn't doing anything. This thing is only used for when the shuttle's actually flying like an airplane. That's why Starship, for instance, doesn't need a tail, because it just doesn't need one. Plasma shield. I mean, Jado, it quite literally is. The shuttle's nose cone, see the gray nose cone? It's blunt on purpose, because it works like a bulbous bow. And I know you're going to type something edgy into chat, I get it. But no, seriously, hear me out. I was reading about this last night. It's so freaking cool. So the shuttle it basically hits the compressed air first, and it shoots the plasma out to the sides. And depending on the speed you're going at is the angle of the plasma bow shock. And guess what? The shuttle's entire fuselage is built around the minimum bow shock angle that you're getting. So it'll shoot plasma out at this angle, right? Like this, at some points during re-entry, right? And that hits right here. Right here is the minimum angle, right, that the plasma can go over. And that's why there's tiles right here on the strakes. That's why the strakes are there. It's designed to move that plasma out of the way. And then the the plasma bow shock from the nose hits the wing edge like this. And that's why there's RCC right here. And that's the other reason why you hear twin sonic booms from the shuttle. The twin sonic booms from the shuttle are from the nose and the wings. Boom, boom. 1, 2. That's why we lost Columbia. Yeah, the plasma. Yeah, the armpit of the wing right here, very critical structural point. And like I said, this is what I mean when we talk about Columbia. It's a freak accident. It hit it right here, right in the armpit of the wing. That's connected. That's a subassembly that connects the landing gear together. That's like cutting down the stump of a tree, and then the whole tree will fall over. That's an Achilles heel right there. If that piece of foam hits out here, you're fine. It'll just bounce off, and the wing would have gotten a little bit damaged. If it goes a little bit higher, it makes it right over the wing. A little bit lower, it goes completely under it. It's like ULA Sniper for the shuttle. That's not ULA Sniper, but you know what I mean? It's like a freak accident. But yeah, the X-37, well, Jacket, that's the thing. See, we have all this information, and you hear bits and pieces of information of the shuttle. The shuttle comes in like this, and gradually does this over time, right? It's not just staying like this until it's through reentry and then nose down, right? The thing will stay like this, and then once it's aerobraked enough to have its trajectory fly over the runway, it'll slowly do this, right? And then it'll do S-turns like this. Like that. Just like I do in KSP, where it kind of wags the tail like this. Kind of just does a huge Doriftu at like Mach 10. Right? So it depends. It depends. And this is what Demo was trying to tell me last night. And I ended up going and reading more about it last night. It depends on the speed that you're going at, because the speed will give you a different plasma wake, which is, dude, it's so fascinating. That's so cool. Yeah, the X-37 also can change its inclination via aerobrake, which is just, I mean, that makes sense, but that's still also insanely cool. It's like getting struck by lightning after winning the lottery. Flash Wolf, yeah, dude, you could have a... I'll say it once and I'll say it again. I've read CABE multiple times, the accident investigation. If that piece of foam hits 5 inches, so 6, we'll just say 6 inches. That's 15 centimeters. If it goes 15 centimeters to the right, it misses the wing completely. That's this much. That's it. If it goes up, the wing, it'll just fly over the wing. It'll bounce off the top of the wing. If it went down, it would miss the wing entirely. It's ridiculous. Like, it's so stupid. Like, out of all the things, that's what happens. Ugh. Yeah, it's kind of annoying. No, Kuro. Landing in the canals at LA. Okay, Kuro, check this out. In the shuttle, they were like, "Oh my gosh, we're off course." After they went through peak heating, they were like, "We're off course, we're off course." So they decided to land in the LA canals. All right, check this out. Okay, all right. Look. So the LA River, all right? There's the LA River, right there. That's where they landed in the movie, right? Right there by this train station, by Union Station. Okay, look. The shuttle's runway is right there. You can see it from space because it's so ridiculously long. It's the runway it's the long runway at Edwards Air Force Base, right? Look, 60 miles. 60 miles away. Now, I get it. The shuttle's gliding. But it was through peak heating, okay? This is what I try to teach Kerbal players, okay? The shuttle comes out of reentry, and they somehow had communications blackout during reentry, which implies TDRS is not working, which is not how that works because they were wearing pumpkin suits. In the movie The Core, they were wearing the orange flight suits, which means it's post-Challenger, which means it's post-1986 in the movie, at least. I'm pretty sure it was in modern times, right? So it was sometime in the early 2000s. TDRS was already set up. They had plasma blackout, which makes no sense. When the shuttle was going through re-entry, right? The shuttle could communicate by looking up at TDRS because the plasma was going underneath it. The plasma off the top isn't as bad as the bottom. That's by design. So they had communications through reentry, no problem. So they come out of peak heating, right? And they come out of the fiery stuff, and they're like, "Oh my gosh, we're off course, we're off course, we're off course," forgetting that they're literally in a glider that they can steer. Yep. So, and once again, this is why I say this is what I teach. This is why I teach what I try to teach people in KSP. Once you're going through reentry, guys, so when you're building a space plane, like Dart, for instance, Dart actually has a problem. It's not that good through reentry. Collins is better. My shuttle was better through reentry. Dart's good enough for right now. But I'll roll out new changes as we go. You should be able to fly through reentry, no problem. You should be able to do stuff like this during reentry and easily be able to change your AOA during reentry. That shouldn't be an issue. All right? The shuttle can do that. It can fly through the plasma. It can fly through plasma, no problem. Like, actually fly. And I do say fly, and people are going to say, "Oh, EJ, it flies like a brick." Nothing flies like a brick when you're going Mach 25. Okay? It flies. It can use the RCS and the control surfaces to steer. So when they come out of peak heating, they're still going like Mach 10. Mach 10 at like 100,000 feet. So that's like, that's like 7,000 miles an hour, which is 10,000 kilometers an hour, 11,000 kilometers an hour, somewhere around there at like 33 kilometers up, or 33,000 meters. The shuttle flies like dog crap. It doesn't fly that much like dog crap to be able to make up for a 63-mile difference. No. It flies bad, but it's not that bad. The shuttle has cross-range capability on purpose to be able to account for problems like this. Not necessarily problems, but it has cross-range capability, and it can change its trajectory. So even if you were, "Oh my gosh, we're off course. Oh my gosh, we're off course," the shuttle is probably coming at it from this way or from this way. If it's coming at it from this way, changing your trajectory that way is not that bad. You would really have to intentionally try to target the runway or target the river, and then in the last like 10 minutes change your mind, which is not what happened during the movie. They were coming through reentry and they're like, "Oh my gosh, we're off course." That's not how that works. The shuttle has a cross-range capability that is quite literally insane. You could take the reentry trajectory, and the reentry trajectory could come, for instance, over Texas, and it could land in Florida. That's usually how that worked. The shuttle usually flew over Texas before it came into Florida, but that depends on if it's coming in on an ascending and descending node. It depends on the orbital inclination. Now, here's the thing. Check this out. Shuttle was designed also to launch from Vandenberg into a sun-sync orbit. So that means it's going something like this, right? It's going somewhere this way. Somewhere that way. And then, because the Earth is spinning underneath it, right? Look at where it comes back up. Right? You see what I'm talking about? Look at where the dang thing comes back up. Now, the Earth is going to be spinning. It's going to be spinning that way. So that tells me that when the shuttle comes back after a once-around orbit, you're going to have to really, really change your inclination hard. See that? Actually, that it would most likely launch, well, no, it would have to launch that way. It would have to go this way. Hang on. Long story short, what I'm trying to tell you is that the shuttle's going over like this, right? It'll do its once around, right? But you have to take into account spinning, right? The Earth is going to spin, so it's going to, the next orbit would be over here somewhere. At the very, very least, right? Because the orbit's, the Earth is spinning underneath. Do you see that distance right there? That's the maximum theoretical distance that the shuttle, that the cross-range capability is. Like, I mean, this is a very, very gross estimation. And we got to make sure the tracks are the same. So, It's a very, I'm just guessing, but the shuttle was designed to launch out of Vandenberg doing a polar once around orbit. So basically the shuttle launches, you have engine cutoff out here, right? You have engine cutoff out here. The shuttle gets over here. It flies over Antarctica. It reacquires signal with TDRS over these islands out here. Flies past, where are we? Sri Lanka. Has acquisition of signal with Diego Garcia. Deploys the payload, right? Keeps going. Flies over the Soviet, well, this is when they planned on doing it, so it was Soviet Union at the time when they planned to do these missions, right? And then it comes back down over here. Because the Earth is going to be spinning. We're talking about a 90-minute change. So, because one orbit is about 90 minutes. So it would have started re-entry over here. And what it would have had to do is something along the lines of this. Something like that, right? And check this out. Want to see something crazy? Look at the heading on the runways at the runway at Vandenberg.
Are you gonna eat the sauce you told me to make, or are you just gonna?
Discovery.
Just
Go and
I had some of it in the kitchen. You can throw it away. It's fine.
Okay.
Look at the heading on the runway at Vandenberg. Coincidence? I think not. See what I'm talking about? This is a 15,000 foot runway. 5,000 meters, guys. It's like 4,750 or something. But see, you can tell that Vandenberg, right? Vandenberg was originally just this. They extended it in 1984 to a 15,000 foot runway to accommodate the shuttle. Because the shuttle was going to launch from Slick 6 down there. So, check this out. What's our maximum cross range here? So you see that turn? The shuttle can turn and change its trajectory through reentry. I mean, the X-37 can do the same thing as well. Right? What are we talking about here? Yeah, okay. See, that makes perfect sense to me. And I just did a rough estimation. 1,000 miles. So that's 1,600 kilometer cross range. I'm guessing that's what it has. Just by what I know about orbital mechanics. Because I know if they launched Sun Synchronous and went south-southwest out of Vandenberg like this, the next time they came around over here, California would be about 90 minutes that way. Because the Earth is spinning underneath it, right? So I'm going to guess, just based off of these numbers, that it's about 1,000 mile cross range capability. So if this is just a ballpark, right? Overcoming an extra 60 miles is no problem. The pilots would be like, oh, we're over Los Angeles. Here, let me flare the thing up and keep the altitude. And then worst case scenario, you go and land on the dry lake bed. Because what are we talking about? We're talking about the core and orbiting vehicle what's called cross range capability. Caviar, 22-month resub. And then James had a 20-monther before that. Guest subs can only post links. What? Yeah, Caviar, it's always been that way. And I'm sure that means right at ultra high speeds, even the air becomes dense enough in relation to what it's going through. Yeah, absolutely. I mean, if you're compressing it enough, sure. Don't forget the raised landing gear. On the dry lake bed, it would have been fine. Last link, please. Oh, yeah. Yeah, there's the frickin'... Oh, well, that's reentry. That's reentry during STS-135. In 90 minutes, the Earth rotates 22.5 degrees. And Aldesert, if I had to guess... So the space shuttle has these big old wings on the side, right? If I have to guess, that's probably the number they picked, and they derived the entire shuttle design from that. I'm pretty dang sure. Because I know, and before you say, what do you mean? Did the Air Force have that much say over the shuttle's design? Well, yeah, the payload bay is to their spec, not NASA's. So 22.5 degrees, let's take a look. So what's Vandenberg at? Vandenberg Air Force Base is west 120. So we're looking at 120 or 142.5. Or no. Did I not do that right? Is it 22 minutes or 22 degrees? I'll desert. Is that the new Lego model? It is bad. No, listen to that specific minute. Astronauts are astronauts allowed to use that language? Sure. What are they saying?
She is going up. Coming up on the cloud deck. There's the throttling.
Yeah, that's Doug saying that.
20,000. 3 at 72.
That's Doug. That's Doug Hurley.
DPDT. Throttle up. What do you see there, Rex? 3 at 104.
He's talking to Rex Walheim.
DPDT is about point 0.07.
In the positive or negative direction?
Negative.
Go with throttle up.
You go with throttle up, no action on DPDT. It's probably just cabin stretch.
Okay.
We concur, thank you.
90 seconds.
Seconds.
Yeah, dude, astronauts can swear. Of course they can. Dude, you should hear what they say on the closed loop sometimes, man. We've heard it. You can hear bits and pieces of it from time to time. Which flight is this? They sound stressed. Caviar, they sound stressed because the shuttle is pulling 4.5 Gs during ascent, 4.5 Gs during ascent. The later parts of, so the later parts of the SRB portion of flight, so from like maybe a minute 30 to like 2 minute 30, that thing is like, it's really pushing you into your seat. Because think about it, the SRB's thrusts do tail off, but the TWR of the shuttle stack with the SRBs low on fuel and the engines and the 3 shuttle engines throttling back up, that's peak G load right there all day. Russians do the same thing. Oh yeah, Vasya, remember when we heard the translator? The translator's like, huh. Like somebody said something and she's like, I love this job. You know, I thought that was funny. Yeah, that was during ascent. The SRBs very, very, from every astronaut testimony I've heard, the SRBs are violent. You have to deal with resonant frequencies, or not resonant frequencies, but very, well, I wouldn't call it resonant frequencies, but long story short, the vibrations from the SRBs can literally unscrew bolts. Like, I heard it. I was talking to an external tank engineer at Space Fest in 2019, and he was telling me, he told me something I didn't know about Ares 1. Actually, well, not about Ares 1. He told me something about the shuttle that I didn't really realize. Remember, you know how I show you guys that bar that holds the SRBs together inside of the inner tank? So on the external tank, there's a bar that holds the 2 SRB hold down points together. It's a strut. It's a huge I-beam strut that's made out of aluminum, and it's like probably about 30 centimeters by like 40 centimeters. The thing is, it's chunky. That holds the SRBs together. But I had an external tank engineer at Space Fest tell me that the SRB vibrations actually, the vibrations get put through that beam and they hit each other and actually cancel each other out. And even with most of the vibrations from the SRBs canceling each other out, the shuttle is still a ridiculous ride. Yeah, Thomas has the link right there. Here, I'll show you. See that? That's the beam. This is the top of the hydrogen tank. There's your hydrogen vent line right there. See, it has a flex joint built into it because it flexes on us? No, because it changes in temperature when you start venting hydrogen, right? Because hydrogen is cold. This is the inspection hatch for the bottom of the liquid oxygen tank right there. And then the downcomer for the LOX tank is on the other side here. The downcomer would pop out over here. Where are we looking? What's our orientation here? Okay. Yeah, the downcomer's over there. Because the shuttle in this, from where this picture is taken, would be over here. The nose of the shuttle would be pretty much right around right here. And the bottom of the shuttle would be right there. So the downcomer is over there. It's on the opposite side of the ground umbilical carrier plate, which is the hazardous gas vent line on the shuttle. And this is going to the GUP right there. So you see that little shiny piece of metal right there? The LOX downcomer would pop out over here, out of the very bottom of the tank, turn, and then go out the external tank, around the hydrogen tank, and down into the back of the shuttle. That's what that huge tube is on the side of the external tank. So, actually, now that I'm looking around, if that's correct, we should have a hydrogen vent line coming in through the inner tank over there, and then coming... Yep, there it is. That's the autogenous pressurization line. If I had to guess, like I'm taking a huge guess here, that's the autogenous pressurization line right there to repressurize the hydrogen tank. I'm guessing that that's the autogenous pressurization line because 3 main engines on the shuttle. I know the size of the lines out there, and it's similar to that. It's actually a little bit smaller. That might not be it. That could be... It's not electrical, and it's not pneumatic either, because the tanks, they use autogenous pressure. Yeah, it's the only thing that could be. The inner tank was unpressurized. Yep. There's vents everywhere. They basically have holes in the inner tank down the bottom, because when you accelerate, all the air goes down and they drain it out the bottom. Most fairings have that. Most fairings have the vents down the bottom. Heck, even the shuttle's payload bay, which is unpressurized. If you look at the shuttle about right here and right here, there's little holes that are in the side of the payload bay on either side. They're not holes directly into the payload bay, but they are vents. They're right here and right here. You can't miss them. Hey, Ruggin, 43-month resub. Did they pressurize the inner tank at all? No. But, yeah, the SRB vibrations really, really screw you up. And that thing helps. It's like a tuning fork for the SRBs, which is kind of weird. On Ares 1, you would have had a problem with vibrations. They would need to put a giant damper inside of the inner stage. And that would have been hard to engineer. I'm not going to lie to you. But the program, Ares 1 got axed before they figured that out. The shuttle used autogenous pressurization. Correct. Here. Yeah, so the tank on the space shuttle has 3 lines, right? There are 3 lines going up, well, 4 technically, going up the side of the tank. See this one right here? Liquid hydrogen repress line. And guess what the one that goes all the way up to the very top of the liquid oxygen tank is? The LOX repressurization line. Now the repressurization line, gases go right in through the top, right here. That's also where the gaseous oxygen vent line is. That's what the beanie cap is controlling when the shuttle's on the stack. It's just a vacuum cleaner that sits up here on top of the external tank. And when they're fueling, right? When they're fueling, I mean, NASA, smart as they are, put the vent line and the repress line into the top of the tank in the same spot. There's just a valve up there, if I had to guess, right? And the beanie cap just sucks the gaseous oxygen away from the shuttle stack. And that's the repress line there, and there's the hydrogen repressurization line. There's the LOX downcomer. See? Check it out. The 2 SRB hold down points on either side are bolted together from that big freaking crossbar, right? And then there's the LOX downcomer. There's tank baffles, internal baffling. Well, the baffling is here. Yeah, that's anti-vortex baffle. You don't want to create a whirlpool in there. That'll cause the thing to do this. What was the cause of Challenger? Wind and a just send it attitude. Really doesn't. That rocket nose sucks. Yeah. Why an inner tank? Why not use a single bulkhead between this tanks like Starship? Well, Reagan, that's a good question, actually, man. So let's think about it for a second. Why? Why would you do this way? See last for what I think you were pointing at. The tube on the structural ring in the top left, that's the purge vent and has gas duct. Cool. Don't worry about the Ares program. It's not something that's a thing anymore. Yeah, Falcon 1 Flight 2 had vortex issues in the second stage, and it caused the second stage to do this and eventually just tumble out of control. Hydrogen likes to go through stuff. Not a bad guess. All right, here. Let me give you a hint. Temperature. That is true. And you're not wrong when I say hydrogen likes to go through things. Temperature has something to do with that. Now, the top, it's very clear that the top of the tank is sprayed with spray-on foam insulation, right? So is the bottom of the liquid oxygen tank. So that means you don't have to worry about exchanging any heat with the air inside of that inner tank, right? X37. So why keep the tanks apart? Reagan, I think you know this. I think you know this. What do you know about liquid hydrogen? What do you know about it? Hydrogen exists as a liquid at what temperature? Hydrogen is colder than LOX. Way colder. Way freaking colder. Hydrogen is about twice as cold as liquid oxygen is. I mean, twice into the negative. The inside of this tank is getting near 0 Kelvin, which is close. That's about as cold, quote unquote, as the vacuum. It's very close. Minus 250 C. Liquid oxygen is what, guys? Minus 170 or something? They need to keep the hydrogen away from the liquid oxygen. Now, that does not mean that you can't use a common bulkhead design with Hydrolox. Centaur has been using a common bulkhead design for 60 years almost, in its different variations. The Centaur upper stage. Now you tell me, this is a real trivia question here. Why does the Centaur have a common bulkhead with hydrogen and liquid oxygen and it's not a problem? But the shuttle's external tank had to keep the tanks separate. Why is that? Think about this for a second. Volume, vibrations? No. Nope. The amount that's present? No. ULA just, with Centaur 5, just decided to make a bigger Centaur stage. No problem. From the SRBs, altitude, atmosphere, structure. Structure has something to do with it. What's a Centaur made out of, guys? What's a Centaur made out of? Tin cans? No, not tin. Balloon tanks? What are the balloon tanks made out of? Rocks! Very small rocks. It's made out of stainless. What do we know from Starship about stainless steel? What does it do? What is it like? What does stainless steel like to do? Stainless steel likes to get cold. So it's not as big of a deal inside of the stainless steel Centaur stages. This is made out of friction stir welded aluminum. If I had to guess, it's probably 7000 series, but that's just pulling it completely out of my tail. Starship explodes! Yeah, right. But it handles the temperature of the propellants really well. It's just when the temperature's explosions doesn't handle it very well. So, Reagan, stages, like with the Saturn V, they took an efficiency hit. But a common bulkhead with Hydrolox was still better than doing an inner tank design because they really didn't have a choice. The Saturn V, as powerful as it is and as crazy as it is, the margins are very, 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 very thin, even with the upgraded versions of it. Now, the S1C, it's interesting because the S1C, Saturn V's first stage, uses an inner tank design. Why? It uses RP1 and liquid oxygen. Why the heck would you use an inner tank design? It's not a mini shuttle replacement immolated, but I think it represents what the Air Force wanted to do with the shuttle eventually. Shuttle ET at the end was 2195 alloy, lithium aluminum. Oh, it's very much, that's Falcon 9. Because they needed to make it lighter? Because they were told they need to save weight. Well, the S1C, an inner tank design is heavier. Why? Because you have two bulkheads. Why was the S1C using an inner tank? Also, the X-37 serves as a test article for the MS-1A project. Yeah, Floating, I saw you say that, but I'm not familiar with that. No, Builder. Falcon 9 uses a common bulkhead with RP-1 and liquid oxygen. Where do they take the gaseous hydrogen? The ground umbilical carrier plate, the GUP. There's a vent line on the back of the external tank. You can see it right there. SLS has the same thing on the core stage, believe it or not. It was harder to develop. Inner tanks might weigh more. They might be bad for efficiency, right? But inner tanks are a lot stronger because they have those stringers in them, right? They're a lot stronger. Saturn V's first stage needed to have an inner tank designed to hold up the heavy second and third stage, the CSM, and the LEM. It has to be that way. It's the only way they could get the thing to stand up. Now, with SLS, you don't have to worry about that because the SRBs are made out of steel. The SRBs on the shuttle and SLS are made out of their steel. They're not even stainless steel, just straight steel. Because, and that's why you can paint them, and it's really not a problem. Because they have to hold up the stack, and SRBs, aluminum SRBs, I'm pretty sure is not a thing. Ryan, date for the first SLS launch. They're targeting the end of this year, but it might go early into next year. How many issues will they have with the GUP before SLS launches? Oh, God, don't get me started. I know guys, Banana Time, that worked on HasGas for the last, 10 shuttle missions. Yeah, one of my good buddies, actually, on the stream. He doesn't post. He lurks. I've hung out with... God, I wish I could tell you some of these damn stories. I've told you as many stories as I possibly can without, implicating anyone, you know? I don't want to just go around being like, oh, yeah, I know this guy. He works here and does this. That's not cool to do. Yeah. So, Reagan, there's a couple of other reasons why you would have an inner tank design with the external tank. The other reason is, well, that. You have to hold those dang SRBs together. This is the primary load carrier for the solid rocket boosters, okay? At the back, the aft attachment point is attached on a seam right there. And if you look, see that huge green plate right there, that ring plate? That's there for a reason. It needs to be strong because the SRB is bolted there. But generally, you do not want to bolt stuff to the side of a tank like this. Because anything that's pushing and pulling on the side of the tank is going to change the outward pressure inside of that tank. And you're going to have non-uniform load on the tank walls. Think about all the rocket fuel tanks, every single one of them that's pressurized. Needs to have equal pressure on all edges at all times. SpaceX had that problem with Starship, with SN1. That's why it popped, because the bulkhead down here, the seam down there it pushed harder here than it did over here, and the thing went off like a bottle rocket, right? Would you want to bolt your SRB to that? Hell no! No way! I wouldn't. That's a really bad idea. No. I mean, with the shuttle, you kind of don't have a choice, and that's why they have a huge flange right there to mount the aft shuttle mounts. And look at the size of that strut. That strut's there to take the load of the shuttle engines, because that strut is at the exact same angle that the shuttle engines are at. Well, within reason, right? So they have a huge plate right here, a big thick plate, so it doesn't do that. So it can take the force, and you still have uniform pressure on the inside of the tank. But you don't want to bolt your SRBs like that, the aft SRB attachment points. You don't want load being transmitted to the external tank right here. Bad idea. Very bad idea. SN1 is a pretty good proof of that. So the aft SRB attachment point right there is just there to hold that SRB true. It's just there to hold it in place. This is the primary structural carrier right there. So the SRBs aren't so much pushing the entire external tank up. They're pushing the liquid oxygen tank up, and they're kind of pulling the hydrogen tank and the shuttle. But the shuttle's engines are firing and kind of canceling out some of that pulling force. So the external tank the hydrogen tank ends up it kind of cancels it out. which is kind of crazy. Once again, it's just a huge load balance. The external tank is ridiculous. The engineering is crazy, considering it's literally just a big aluminum hydrogen tank and a big aluminum oxygen tank. And they managed to do all this load simulation with this thing and get it right to have a 60-ton orbiter attached to the side, thrust being applied on a cosine with a cosine loss this way, right? And also big SRBs attached to the side. So you have force impacting the external tank like this and like this, which is still crazy to me. It's a really remarkable piece of engineering. In the 70s on a drawing board, I might add, yeah. Why are the SRB mounting points up so high? Once again, you don't want to bolt, shortline, you do not want to bolt anything to that hydrogen tank. Trust me. This is going to be a little bit on the morbid side, but the O-ring on Challenger on the right, on the starboard SRB, right? It burned through its attachment point. It burned through the attachment point and then did this. It did this, and it went into the, it fractured the hydrogen pressure vessel right there, right at the inner tank. That's, force isn't designed to be applied on this way. It's designed to be applied on it this way or this way, and that's it. The external tank doesn't fly very well backwards or sideways, right? So that O-ring blew right on the aft orbiter, the aft SRB attachment point and caused the SRB to do this. You could see the shuttle sequencer computers trying to compensate up until, yeah, don't go and watch that. I'm not showing that if you don't like watching stuff like that, but it's just an interesting piece of engineering. Where's the payload bay? Well, the shuttle would be, Baronog, the payload bay is up here technically, right? I really wish someone would just SSTO a first stage just because. SpaceX might do that with a Super Heavy. I know all you are looking at me like, huh? This is one of EJ's wild theories, and that'll take us back into Starship, right? Papa Bear. Starship is very, 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 very dependent on having fuel depots in low Earth orbit. Its entire architecture depends on it, right? Dedicated fuel depots, not just a Starship tanker that flies up and refuels another Starship. If SpaceX has really no problem making ground service equipment out of Starship tanks, I don't really see why SpaceX wouldn't have a problem with having OSE, orbital service equipment. Meaning, take a Super Heavy, right? Take some of the engines off, because you don't need 28 Raptors. Maybe like 5 or 6. Fill the thing up with fuel. No Starship on top, right? Up into space. Tank depot. Yeah, I don't see why SpaceX wouldn't do that. I mean, it's not the worst idea. I mean, I have no evidence to support that they would. It's just kind of an opinion on my part. So imagine you build a space station that's a bunch of Super Heavy boosters just kind of on a truss segment like the ISS, right? And then a Starship could just dock to that, refuel, and go. You could stockpile propellant in low Earth orbit. Yeah, the Super Heavy would need to have a detachable nose cone, and the nose cone could be just the front of a Starship, right? And then it could pop off once the thing gets high enough up in the air. The first stage clearly has no problem flying through the air inner stage first after the second stage of Falcon 9 flies away, right? So you would need to make a Starship nose cone that just... No need to refuel, just connect the booster in space and go. I mean, if you wanted to do that, I suppose you could. Why is the SLS only going to launch once a year? Ryan, I don't think that it will. I think that Congress will push for 2 launches a year. Ryan, if I had my way, it would be 4. I would want 4 launches a year from SLS, but I can dream. I mean, theoretically, Starship is a Mars SSTO. It is, Flash Wolf. Yep. This is the stuff I wanted to learn when I was like 7. I got a book with 1 page on rockets that had an arrow pointing at the bottom saying engine. Iron Spark, What I try to do here is show... Hey, Waller, thank you for the raid. What I try to do is show people the end goal of this stuff, all right? I will show you what the end goal of this is. It's like when you play a video game and you meet the boss at the very beginning, and then you have to play through the entire video game, and then you beat the boss, right? Or like, have you guys ever played a car game where you, like at the very beginning, it gives you the best car in the game, and then you have to work your way back up to that best car? That's what I'm trying to do here. I'm trying to show you guys what it takes to do boss battles, like meaning engineering rockets that fly into space, and, you know, in terms of SpaceX, reusable ones as well. I'm trying to show you the end goal, because I know that when I was younger, if someone told me the end goal and didn't just say, you have to study, you have to study, you have to study, I didn't really care what they had to say. Why do I have to study? I don't see the end goal here. So I try to show you that. Because nobody did it for me. How would they keep it cold? A thermal shield goalie? Waller, thanks for the raid, man. What were you doing? Were you playing KSP? Probably easier to make a long, simplified version of Starship rather than waste all those sea-level Raptors just sitting in orbit. It wouldn't need that many entropy. You wouldn't need 28, that's for sure. 10. And then Starship could just go and detach them. I mean, if we're gonna using a super heavy propellant depot, having a super heavy propellant depot in low Earth orbit is something that SpaceX would do. I'm kind of, in the context of things, that means Starship works, and it works like being able to launch all the time. But yeah, why does the LOX tank on the external tank have spray-on foam insulation? It keeps the propellants cool. It actually does control boil-off really well, Reagan. You get, if you can store, if you can get less LOX boil-off, right, you can get more performance. And you got to remember, this isn't a Falcon 9. SpaceX uses densified propellants, right? And honestly, densified hydrogen is... That's something that could be done down the road, I guess. But they can't densify the propellants. They didn't with the shuttle program. NASA was actually afraid of that. Even before Almost 6 happens, NASA was afraid of that because they knew the challenges of densified propellants, right? If you could say, just play theoretically off me, you could densify the propellants on the external tank, the orange would keep it even cooler for a longer period of time. It's literally, okay, you ever be out on a summer day and you have a can of soda and you put the soda inside of the foam, the koozie, right? The foam koozie, and it keeps it cool for a long period of time. That is literally the spray-on foam insulation. It's the same thing. It's not the same thing, but you get the idea. Same concept. It keeps the propellants cooler for longer. Falcon 9 on the first stage with the densified propellants only needs to stay cool for, I don't know, 2 minutes, 30 seconds on ascent. And then maybe another 15, 20 seconds of burn time for the entry burn and landing burns, maybe. So that's like, what's the total amount of time? And keep in mind, it's flying for about 8 minutes. But the shuttle engines need to be firing, and the external tank needs to be firing for 8 minutes. Right? That's a long time, dude. You need to keep that hydrogen and oxygen cold. That's why even on Atlas 5, the Centaur is still sprayed in foam on it. It still has spray on foam insulation. It still has it because it needs it. And I'm willing to bet that Vulcan probably will too. Delta 4, same story. So Super Heavy being built. There's a Super Heavy Booster 1, Ryan, is assembled right now. At least the tanks are. SpaceX is going to use it as what's called a pathfinder to be able to kind of figure out how to move a freaking... how tall is it? A 200-foot stage around? Ryan, the first stage, Super Heavy, is about 220 feet tall, 210 feet tall, and about 30 feet wide. They're using BN1 as basically just a dud to figure out how to freaking move that thing around. And it might see a pressure test. Who knows? How do you even make liquid hydrogen or liquid oxygen? Well, you need to distill it. Builder, not an easy thing to do. A lot of energy required to do that. Basically, with hydrogen, you need hydrogen gas, and you can find that. That has plenty of hydrogen gas has plenty of industrial applications, right? Or you could extract the hydrogen from petroleum, if I'm remembering correctly. So you need hydrogen gas, and then basically what you got to do is you have to distill it, and then you have to freeze it. That's pretty much it. I mean, I say that like that's some easy process. Like, it's not. You see the new Humvee? Yeah, Sawyer, I know about it. Fun fact, old Centaur used to have to jettison insulation panels during ascent. Interesting. Have you seen the Tank Depot idea from SpaceX Vision on YouTube? I have not. Mega tanker concept. Yeah, I saw the mega tanker thing. That's not a bad idea. But, I don't know. Yeah, you could split water, Ando. That's probably a lot smarter. You start with water, split it, and get oxygen. And take the hydrogen, and you have to freeze it. And if you freeze it, you can combine the two. You could take basically the H2 out of water, and it'll make gaseous hydrogen. And then from there, you got to keep it really cold, or else it'll leak. And then you just freeze the thing and just keep it frozen. Do you think SpaceX will spray on foam on the GSC's tanks made of Starship parts? Probably not, Reagan. They might paint them, but Reagan, you tell me. You already know this. What did we say about Centaur? What's Centaur made out of? Stainless steel is actually really, really good at dealing with cold, so it's fine the way it is, and that's why none of the starships you've seen have had any type of insulation. It's just stainless steel. Stainless steel is good at that. It's good at dealing with the temperatures. With cold temperatures, it actually gets stronger, right? On a side note, for structural bonus there, and then also it's a little bit it's better at dealing with the cold propellants. It can insulate a little bit better, but that's at the expense of mass. That's why on Centaur they make a balloon tank. Centaur's walls on like Atlas V and Vulcan's upper stages are about that thick. Like half of a dime, maybe. It's like 2 to 3 mil, which is nothing. That's nothing. What are the advantages of using LH2 over LCH4? Well, it's more efficient, Builder. You get a more efficient burn. You don't get as much power, but you get a more efficient burn. So with a hydrocarbon, so with like Keralox, right? Kerosene, liquid oxygen. It's a hydrocarbon. What's a hydrocarbon? It's chains of carbon and hydrogen. CH, 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 and a long choo-choo train. And they're in nice big strains. That's petroleum. That's basically what petroleum means, right? I mean, there's tons of different types of petroleum, etc., etc. So when you throw that into a rocket engine, right? You want to burn as much of that as you can, but you usually don't get all of it. Okay? So it's inefficient. It's an inefficient burn because what gets ejected out the bottom, you're not efficient because you have some unburnt material coming out the bottom. Cars do this. Cars are notorious for inefficient combustion.
Go at throttle up.
They're notorious for it. That's why cars in the 60s are these big blah, 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 blah. Because their solution was just make a bigger motor to make more power, not make power more efficiently. But then again, there's only so much efficiency you can get out of gasoline or in a rocket's case, RP1. There are ways to get around it. The Soviets, with the oxygen-rich stage combustion cycle, found a way to deliver more oxidizer and get a more complete burn, right? That's literally what like spraying nitrous into a car does. That's the same thing. You can spray more oxidizer, you burn off more of the fuel. You can spray more fuel, more oxidizer, you get a more complete burn at the expense of a higher temperature. On a rocket, Keralox is very energetic. It explodes real good. But it's not very efficient. That's why first stages on rockets use Keralox, and in the case of like Atlas V, you have a Hydrolox upper stage, because Hydrolox is very efficient. It gives you decent thrust for a very long period of time. But there's another trade-off here. Engineering is all trade-offs. It's a big pain in the butt because thermodynamics, mostly in this particular case, thermodynamics sucks. I want to punch the guy in the face who made those laws. Can we veto those? Can we, like, change that, please? No. Hydrogen is very, very, very difficult to work with. It's not very stable. That's why the tank has orange foam on it. It needs to stay cold, and it's very easy for hydrogen to not stay cold. The other thing is that hydrogen doesn't like being pressurized. It really doesn't. And what do you need to keep a gas as a liquid inside of a rocket tank? You need it to be pressurized. Other reason why the tank has foam on it. It needs to stay cold. Temperature is crucial. See last for the LH2 question. Sure. Okay, Novus, I'll read that in a moment. So, if you overpressurize a hydrogen tank, and this is one of the reasons why densified hydrogen is so hard to make, if you overpressurize hydrogen in a tank, the fuel tank will work about as good as squeezing a sponge and hoping the water stays in. That's the pain about hydrogen. You know how Delta IV, when it launches, it lights itself on fire. What do you think that is? It's hydrogen leaking out of the engines. Hydrogen goes through stuff. Because hydrogen, small. It's the teeniest element we know. Seriously, element 1, hydrogen. Yeah. It goes, so if you have aluminum, right, and you have a tank that's made out of aluminum, guess what? At certain temperatures, the hydrogen will go right through it. Just go right through it. That's what it does. Squeezing a sponge, man. So hydrogen is very efficient, but it's hard to work with. Kerolox is inefficient, makes a lot of power, and it's super easy to work with. That's part of the reason why Elon Musk, with Falcon 9, made the first and second stage use Kerolox to simplify the propellants. That's one of the reasons why Falcon 9's costs are so low. The Russians do the same thing. Even Buran. A lot of folks don't know that Buran, I mean, this is a space shuttle, but Buran has orbiter maneuvering engines that are built into the back. There's 2 of them right here, right? Kerolox, not Hydrolox. Kerolox engines. Look it up. The back of Buran is using cryogenic propellants. Semi-cryogenic. Crazy, huh? You can keep it insulated if it's inside of the aft orbiter segment, so it wouldn't be that big of a deal. But yeah, the space shuttle uses hypergulls for its orbiter maneuvering system, so it can stay up there. Yeah, Core. Kerolox OMS. Crazy, huh? Propellants are super interesting, man. Super interesting. All right, Novus, let me read what you were saying, and I'm going to put this down here. I'm just going to make sure I put it out of the way so I don't kick it when I go to get up. There's also a mass flow issue. Yeah, I mean, hydrogen, long story short, it's a big pain in the butt to work with. Methane is a good builder. Methane is a good intermediate. It burns pretty efficiently, right? It's easier to handle, and you could still use it enough for a first and second stage. That's why Elon went with it. It's a good intermediate. There's also... okay, Novus, what did you say? So to make liquid hydrogen, you have staged refrigeration cycles that get progressively cooler. Usually they use different working heat transfer substances in each loop. I think it's called cascading refrigeration. That makes sense. Yeah, Novus, that makes perfect sense to me. Because, yeah, you wouldn't want your temperature delta during refrigeration to be really high, because then phase change will happen, right? You change the temperature really fast, solids turn to freaking liquids, liquids turns to gas. You could have your liquid turn to solid if you try to change the temperature too much too fast. That's the problem that SpaceX had with densified propellants, right? At least I think. Yeah, methane can be made on Mars, that's right. Dreamwalker, it's a cool set. Just make sure you get some time. You devote some time to it. That set is a little bit complicated. It takes a second to put it all together. What keeps Falcon Heavy together, and how do the side boosters not move up and down a lot during launch? T-Man, the Falcon Heavy center core is not a Falcon 9. SpaceX originally had the idea of just taking 3 Falcon 9s and strapping them together. That's very difficult to do. Falcon 9, and once again, this is a load problem, all right? So T-Man, what do you mean? What do I mean a load problem, okay? So think about it like this. You have the Golden Gate Bridge, okay? Say we just took the Golden Gate Bridge away. And then we took the Empire State Building that's in New York, somehow lifted it up. It should be long enough to bridge that gap, and you took the Empire State Building, laid it on its side, and tried to use it as a bridge. What's going to happen? Hey, Envy, what's going on? What's going to happen? Why? A building is not designed to be a bridge. A bridge, and coincidentally, if you took the Golden Gate Bridge and did this with it, it would just... Right? Sorry about that. That may peak the mic. Right? Why is that? A building is designed to resist gravity, or resist gravitational acceleration on its long axis. A bridge, which is going like this, which is longer than it is taller, right, is designed to resist gravity from the side, on the transverse axis, right? So the not major axis of the bridge. Up and down, right? Bridges are longer than they are taller. You can't take something that's designed to be tall and put it on its side. Okay? Now, why is that a big deal? Well, with Falcon Heavy, that center core, where is force coming from? Force is coming from the bottom, obviously. Well, you already took that into account. But force is also coming from the sides. Right? That's why SpaceX had such a hard time with Falcon Heavy. They needed to reinforce the center core. Because they basically took the Empire State Building and tried to make it into a bridge. See what I'm talking about? The Falcon Heavy center core, I wouldn't even call that a Falcon 9 booster. No. It's a Falcon Heavy center core with Falcon 9 boosters attached to the sides. Have you read Ignition, a great book about the development of rocket propellants? I know about it, Serial. People keep telling me to read it. I read Rocket Propulsive Elements. That's RPE 8th edition is what I have. That's where I get most of my info on rocket engines. Why stack them in line and not a triangle shape? Well, what's a triangle shape going to do? Oh, no way, Mike. Oof. When was the last time Falcon Heavy launched? Arabsat 6A? Little over a year ago, if I'm remembering right. We have USSF 44, which is happening in the summer. Was it SDP2 or Arabsat 6A? I forget which one came first, Reagan. SDP2? Cool. Yeah, Zero Port, I gotta go read Ignition. Well, Mike, don't do drugs, man. Well, don't do too many in this day and age. Seriously, you shouldn't mess with that stuff. Like every booster touching each other. Okay, Elliot, you have... Okay, question. I'll humor you here. So, you have 1, 2, and 3. You have 3 boosters, right? Where are you gonna put your upper stage here? Now remember, forces, right? If you put your upper stage directly in the center, right? Now, if you're looking at the booster, if you're looking at any one of these 3 boosters from the side like this, you're applying force right here. Booster's not designed to have force applied right there. The booster is designed to have force applied right in the center because it's a perfect circle, right? It's a pillar. Cylinders don't work very well if you don't push down directly on the center because force is getting applied to one side more than the other, right? That'll throw the whole thing out of balance. Pillars are literally the reason why this thing is still standing 3,000 years later. Well, it's not 3,000. Say, what is it, 2,500? When was this thing built? Hold on. That's the Parthenon in Greece, by the way. Okay, 2,500. We'll say 2,500 and change. So I was close. Only 500 years off. Whatever. That's just at a time for the entire civilization to be created. Whatever. Are there upgrades planned for Falcon Heavy? Fairing upgrades, yeah, absolutely. SpaceX, when they won the National Space Security launch contract, the Phase 2 LSP, or Phase 1 LSP, The Air Force is going to pay them to give Falcon Heavy a fairing that's like double the size of a regular Falcon 9 fairing. And they're going to have them build a mobile service tower for it, Reagan, at 39A. Very similar to Delta 4's MST at Slick 37. Yeah, just like that, actually. Why? Loading spy satellites on. That's the reason. Spy satellites have very sensitive optics. Satellites are the same way. This is why some satellites need to be vertically integrated as opposed to one that you could just attach to the front of Starship and just be like, yep. Or Falcon 9 and just, right? Just turn it. Some satellites are only designed, they're built like a skyscraper. Can't turn it on its side, it'll bend. And in this particular case, a spy satellite, for instance, and this isn't just true for US stuff, it's true for anyone that launches spy satellites. You have very sensitive optics in there, right? You don't want that, like, moving around. You don't want it bending, because if you bend it and the thing goes like this and you bend the telescopic tube, the telescope ain't gonna telescope anymore. Or in this case, the camera isn't going to take a picture. You're going to go to take a picture of, like, Germany, and it'll show you a picture of the Mediterranean or something. No, it won't. The light doesn't work like that, but you get the idea. It's full of anecdotes from a guy who worked in the industry from the start. Just don't get started by the chemical formulas. Rocket science is everything, Serial. It's chemistry, aerospace engineering, mechanical engineering, electrical engineering, software engineering. It's everything. It's every single form of engineering. It's thermodynamics. You're dealing with thermodynamics. You're dealing with loads. That's why it's so complicated. Because it's literally... That's like taking all the other engineerings and combining it into one. That's why I can use a civil engineering example when it comes to making rockets. Because rockets do follow the same principles of a skyscraper, because most of them are as tall as one. Funny how that works, huh? That's hot dogging. What's up, Nez? I don't think so, Builder. I think it's on the top, but who knows. Anyway, a little bit of a tangent there. That was fun. I like talking about this. Haven't talked about propellants in a little while. Anyway, let's go keep looking at Starship stuff. Let's see what we got. Not bioengineering yet. I'm pretty sure they're growing plants on the ISS floating. And also, there's biological components to this because humans launch into space. So now it's medical. Now you're putting medical in there as well. Flight surgeons, medical, stuff like that. It's really just all the most complicated fields of engineering just in one. Who knew? That's why they say it's not rocket surgery, right? How do they transport them to the Cape for launch if they can't go on their side? Who says they transport him to the Cape? Are you saying that, Goalie? I didn't say that. Did you say that? Oh yeah, Vandenberg Falcon Heavy as well. It's pretty cool. Do you have any idea how Falcon Heavy center booster is different than a normal booster? It's structurally over-engineered. It's heavy. It's heavy because it's thicker. Long story short, I don't know the exact details. I know because of loads and what I was just talking about with loads, like side load and up-down load, that it's way stronger. I just don't know how. My guess is they probably have a thicker tank wall, and probably the stringers inside, the internal baffling stringers, which are structural and they prevent slosh, are probably thicker, if I had to guess. Or maybe the Cape is transported to them. I don't know, Theix. Super Guppy? That's NASA's, not the Air Force's. Takes 2+ hours to watch a 20-minute video, lols. Do you want me to stop? Would Starship be built at the Cape then? I don't know, Ryan. I seriously don't know. If I was SpaceX, and with SpaceX planning on launching stuff how they launch stuff, they might just launch it out of Texas and land it in Florida. Who knows? Oh, give me 1 second, guys. I'll be right back. 1 moment. I'll just be 1 second, guys. I got an email that required urgent attention. I'll be back in a moment. Sorry about this. All right. Let's see if there's just one more vid, and then we'll kind of go from there, dudes. Yeah, I'm working on a side project right now, guys. I can't talk. I can't say what it is. I don't want to say what it is, because, yeah, don't want to say what it is just yet, because the plans aren't really finalized. But I got an email back on one of these projects. And like, once again, you know, I know I'm always late for streams and stuff because I'm like, oh, I stay up all night. I stay up all night trying to do side projects and stuff and reading about space on top of that. I do, like, right now, I'll be honest with you, I have like 3 or 4 background things going right now. 3 or 4 like background projects. And this is one of them. And, you know, I always like, what I try to do is I never try to be like, nah, I don't want to do that. You know, I always try to make the project go, and if nothing comes of it, nothing comes of it, you know, but I had one that's actually moving into the project that I'm working that's actually moving into the, like, actually could happen. So I got an email about that just now, and I'm trying to get that figured out right now because it's a time sensitive one. How many trucks have you bought? Trucks? What are you talking about, man? I don't know what you mean. I do have some footage here with Russian news of the MS-18 Soyuz being encapsulated here, so I'll probably flip us over to that here, and we'll check that out. It's 4.5 minutes. They're gonna sleeve the Soyuz inside of its fairing, and then show the crew departing crew ending ceremonies in Baikonur here. So, yeah, I'll be right back, guys. Trust me, if this project goes through, it's gonna be some pretty neato content for the stream. Oh, that's interesting, Thomas. Cool. All right, I'll be right back. 1 second.
Значит, сегодня мы проводим первую тренировку на корабле. Корабль готов. Вы там все осматриваете, тренируетесь. Какие вопросы, все специалисты здесь. Ну что, когда начинаем работать? Все, спасибо.
Так хорошо в маске.
Правый нос он чешется. Здоровка цель. Нашел Сережку? Спасибо.
Ну, сейчас глянем. Он сейчас другой покажет, и запомнит, что вот нам не новинка. Спасибо. Петр. Еще дальше, ребят, да.
Спасибо. Прекрасно.
Ну, у них еще по расписанию час 10.
Signer, there is a hatch in the fairing. Yeah, there's a hatch in the fairing, and the main hatch for ingress and egress is actually in the orbital module. It's right there. That's the orbital module. That's where the hatch is to get into Soyuz when it's on the ground. That's Oleg Novitsky right there. Yeah, it's in the orbital module. So when they actually come back down, the orbital module is actually separated, and they just use the hatch to the orbital module right behind Peter Dubrov right there. That's the hatch into Soyuz. This is the orbital module. Soyuz is down here. They're sitting. The seats for Soyuz are down here, so they go down and in. And then when they come home, this module that says Yuri Alexeyevich Gagarin on it. By the way, it's the capsule to commemorate Cosmonautics Day in Russia, which is April 12th, which is the day Yuri went into space in 1961. Yeah, they just used the docking hatch here between the command module and the orbital module. Did your camera die? No, I'm just answering an email crash. I had a very an important email to kind of deal with right now. Why does the Dragon spacesuits not have all the hose attachment points? They do, Ryan. It's just they keep them kind of concealed. It's concealed. It's more old school. And also, are those waste gates? Those look like waste gates right there, like a pressure relief valve. Wasn't April 12th also the day the Titanic sank? I think so, Arctic. But I mean, it's kind of sad news. But on a better note, April 12th, 1981 was the first flight of the space shuttle. If that helps. But yeah, here, hold on. I'm almost done with this email, guys. I had to write a little bit of an essay out here. Trust me, everything is kind of, all these background projects are kind of picking up because the world is getting a little less crazy nowadays because of these uncertain times. So yeah, I'm been getting a lot of different emails about a lot of different projects happening all at once. Cardboard cutout of EJ can talk. Well, that's the auto streamer, Sneaky. I have the auto streamer on. Also, that's a suit pressure check. And these are formed seats. They form mold each seat right there. See the insert right there? That's form fitted to each astronaut and cosmonaut.
Глянем. Он другой покажет, и запомнит, что вот нам не дают, красиво.
I know, I have the mic unmuted. I'm almost done here.
Еще дальше, ребят, да.
How many Crew Dragons will NASA launch a year? Two, three. It really depends. It depends on the ISS manifest. It could be either 2 or 3 at best. Nice, Signer. There you go. It's like a racing driver's seat, Arctic. Yeah. I mean, Arctic, if you... Here, hold on one second. If you... Here, we saw this already. If you go and look... Here, you want to see something cool? Look. Look at the harnesses, Arctic, for Dragon 2. Okay? Let's see if we can... Oh, there we go. There's... Oh, she's the astronaut from Masters. Sunny Williams. Look at the harness right there. What does that look like to you? It depends, Supercraft. I don't know if that's including the Axiom launches. I mean, he said how many Crew Dragons will NASA launch a year. It's a 5-point. Yeah, that's a 5-point harness from a race car. It's straight up a 5-point. Not like that. Like that, see? So it's a race car harness. Why use what works? The G-loads involved during a launch, and the G-loads involved driving around lateral G-forces and also forward and back in case you get into an accident are very similar. No problem. Yeah. SpaceX, use what frigging works. It's a good idea. All right. Okay, cool. All right, let me just send this back. I'm just going to proofread this email. I typed that email pretty fast. I'm just going to proofread it real quick, make sure I didn't make any typos. I hate sending an email and being like, oh. You go back and read it and you're like, yes, I have to go bathroom the. And you're like, oh, damn it. All right, give me 1 second. All right, just proofreading. Give me 1 second. You should always do this. Read the whole thing again, out loud if you have to. I usually proofread the email like 3 or 4 times, easily. It's like that when I ask you questions. Yeah, I know. If you guys make typos, unless we're screwing with each other, if you guys make typos, I can usually extrapolate what you're saying. Okay. Not sure how these people go around with collaborating with people. Okay, that's good. Cool. All right, we're good. Send it. Done. All right. Reading it sentence by sentence from beginning. That's actually what I was just doing. I read every sentence and then just read it again. I double proofread every sentence. That's how I do it. Nemedco, what is this? Sorry about that, guys, once again. Oh. Okay. Oh, now that's pretty neat. All right. Okay. Cool. Now, we'll finish up here with some Russian news, and then we'll go from there. What did you guys see during that Starship stuff? I was writing that email out. Anything new? I know we have some squishy raptors. There's a picture.
Listen, Tranquility Base here. The Eagle has landed.
Wibble wobble boom lift. Okay. What is this? Second best pun I've ever encountered in the wild was when I was walking down the street in a hip part of Seattle and saw a couple of Budweiser cans thrown into a bush. And I said to a random stranger walking nearby, "Dang, the local beer harvest is really poor this year." And the random stranger responded, "Give it time. They're only buds." Why is this the second one? What could top that? Oh, dear. Oh, dear. And then I have some SLS news after that. Alright, so close that out. Sorry, I'm like proofreading it again. I'm proofreading my freaking sent email now at this point because I'm like, dude, I'm telling you, if that project, I want to tell you guys about it so bad, but if that project goes through, I think you guys will enjoy it. Man. Why do fish live in salt water? Because if they live in peppered water, they just sneeze all the time.
Discovery, go at throttle up.
Did a nice feller in a Minnesota garage decide to get himself a Mopar? I couldn't quite tell what the sneaky peeky was, but it looked like a Mopar. I fell asleep halfway through that episode last night, Buck. Derek is my... Vice Grip Garage is like, I know some people fall asleep to the stream, right? Like, I'm the stream that you use to fall asleep. I'm the background noise. That's fine. First of all, I don't care. Vice Grip is my background noise. You know? You trying to get on Deer Moon? No. Just put the email up on the screen and we can proofread it. Nah. Not doing that. If that one goes through, man, it's gonna be pretty legit. Interview with aliens? Yeah, how'd you know? Yeah, that one's gonna be pretty neat. I'd love to see you do Deer Moon. I actually missed the date catching. Like, guys, how stuff used to work before COVID and stuff, I'd save this kind of stuff for after the stream, or if it was an important email, like I would go AFK for a second. That's how I usually do it. If I go AFK for a second and I say I'm going to pee, right? I'll check my phone, check the emails, and make maybe a 5-minute break and then come back. Like, that's usually what I do during break. You know, I sit here, I eat food, you guys link up the space news, and I check my email and I answer emails. But, once again, because everything's starting to happen again, it's all coming at once. And I'm, still basically doing quarantine streams. I mean, I've dialed it back a little bit. It's only 12-hour streams now. Pre-COVID, it was 10-hour streams. You know, through the heart of COVID, I was doing 14 to 16-hour streams. This one's going to be a long one, but that doesn't matter. Is this the before time of what you speak? Yes, the before times. Nemetco, an RD-171MV. Did they release the test footage for it? Oh, yeah, I'll have to check that out. I don't think you could, Jado. Good times are here again. I hope so. So yeah, all this stuff's kind of happening all at once. I wonder what this tweet is. Tweet says it's been in orbit for 8 years. I don't know if it's a typo or what, because a year would be the X-37. If it's indeed 8 years, then this photo might be of an enhanced imaging system. What? What is this? Alright, we watched that Russian video. We'll finish up with more Russian stuff there. Let me look at this. Interesting. As a European, I love the 12 p.m. start time. Thanks for that. Yeah, sure, no problem. Still doing Minmus today. Yes, Minmus is on the table here, and we got to basically do it now. Could the space shuttle land on water if needed to? The space shuttle landing on water would be about as good as a 747 landing on water, so no. No, it would be extraordinarily bad. If the space shuttle had to do any type of abort nuggets and it was too far down range, the scenario isn't fly it back to a runway, all right? If you're too far downrange to get to a runway or anything, the scenario is basically slow down, re-enter, jump out while it's still flying. That was the abort scenario. Jump out where they're still flying. That's why the astronaut suits are parking cone orange, so you can see them in the water if they have to bail. That's the reason. Yeah, the aces, the pumpkin suits. Yeah, they're orange. They're parking cone orange because you can see that really easily in water from the air. I wonder which is heavier, the 747 or the space shuttle. 747's heavier. They have chutes? Mm-hmm. What's the chance they get nailed by the wings if they bail? Well, first of all, Apatoxin, if they bail, they're going out the top. They're not going out the hatch on the side. The windows. The windows pop out. Yeah. Yeah. That's the reason why they basically just rebuilt the shuttle engines every single time. You do not want that to happen. Yeah, basically, the shuttle has what's called a blackout during part of its ascent. Basically where there's no escape option. Yeah, that was the Achilles heel of the shuttle's design. But, once again, when NASA first started making the shuttle, they weren't planning, it was supposed to be like an airplane. So an aborted launch would be about as out of the norm as an aborted takeoff. You know what I mean? That doesn't happen very often. You know, even if a takeoff enters some kind of an abort scenario, you have an engine out, right? You could still basically just come back to the runway or just get up to altitude and then figure out a solution. That's usually what pilots are trained to do. I talked to plenty of pilots when we played Flight Sim. If something really bad happens, you call the tower, you tell them you got a problem. The tower will tell you just to get up in the air and stay there if you can. And then they'll vector a run, they'll find a landing solution for you. The shuttle had something similar to that, which is called an abort to orbit, or ATO for short. But see, the problem is the ATO regime happens probably like 6 minutes and further into flight, where the shuttle will just put itself into a lower orbit than originally intended. If there was like an engine failure, it only happened once on Challenger in 1985. But could the space shuttle be modified to land in water? Farway, modifying a spaceship to land in water is about as useful as modifying a steam engine to work in space. Yeah, no. It's a different piece of transportation. You wouldn't use a steam engine as a boat, and you wouldn't take a steam engine unless it's what's that called? The car steam engines that they made 100 years ago. You generally wouldn't do that. You wouldn't take your car and drive it into water unless you're James Bond or something, right? Yeah, Fixter, it's pretty cool. Steam engines don't work in space? Yeah, I know. Peepo G, write that down. You heard it here first. Wait, I used the emote in the correct context. Did I? Nah, doesn't matter. Steam engine would be very efficient in space. It's all about that pressure differential. Yeah, right, yeah. Open cycle, though, in space. But then again, a rocket engine is too, Tessa, huh? The shuttle would stop pretty fast once it went in. Dude, do you guys want to see the abort scenario for this? I'll show you it. And once again, we got a deadline, but here. This is pretty much death. So watch. Who does this video? This is Tom Evans. This is, I don't know where he got the comm loop here or something.
Roger roll, Discovery.
I think it's from a simulation, all-up simulation, but watch. Okay, so the shuttle's ascending, right? First of all, there is no abort scenario here while the boosters are still attached. Now you've entered RTLS. The return to launch site abort here. You're in the window for it. From here to when they announce Discovery, negative return, that means you're outside of the RTLS abort window. Basically, you're too far downrange to turn around and come back. After RTLS, you have abort to orbit or AOA. Actually, no. I actually haven't gone through this spiel in a little while. You have TAL, transatlantic abort. Basically, land in Europe. You're too far downrange to turn around to get back to KSC. Land somewhere in Europe. A lot of runways in Europe in the 80s were extended at different airports, and the U.S. paid for it. It boosts, having a bigger runways, better infrastructure, you get bigger planes in there, but it's for that. It's for the space shuttle to land. I know, fake EJ's still up. I got it. Sorry. Yeah, you know how I get with my space shuttle. Yeah, I know, Vanguard, right? Can you depict it with the Lego, please? Oh, jeez. No. This is a better way to do it. The shuttle cannot abort with the boosters attached supercraft. There's no abort scenario from here, from launch to here. Nothing. There's nothing you can do. Yeah. But once again, the intention, and I know if you think about this from a spaceflight perspective, that seems idiotic. Right? Could it abort with liquid boosters? If it had liquid boosters on it, sure. But how are you going to separate the shuttle from the external tank while the engines are firing? That's like, doing that is like trying to unscrew a garden hose while the hose is still on and not spilling any water. You're going to get tank disconnects all happening at once. And granted, they could do it, but what's going to keep the shuttle from like hitting the external tank during a separation? It's not a good idea. Now, a lot of people say, oh, that's the Achilles heel. The space shuttle has no abort. Well, you got to remember what the shuttle is supposed to be is a 747 for space. It's supposed to be, it's a space truck. Or it's supposed to be, quote unquote, an airplane that flies into space. When the original designers designed it, they anticipated so many flights from this thing that it would achieve flight maturity after a couple of years because it'll have flown a couple hundred times. That was the idea. The shuttle was supposed to launch once a week. It was supposed to launch basically on the frequency that Falcon 9 launches on right now. Right? So an airplane basically has no abort once it gets past V1. There's no coming back to the launch site. You commit to the takeoff and you go. Same idea. It's supposed to be more like an airplane. You got to think about it more like an airplane taking off and less like a rocket taking off. It's not a Saturn V. It's the shuttle. It's different. Now, once again, that came back to bite us, I would say, pretty badly. But also at the same time, if you're going to predict hundreds of flights, you should probably test your boosters and shuttle engines hundreds of times, right? To simulate the wear and tear that you'd get from launching a shuttle a lot. Yeah, they didn't do that. They tested it like once. Twice, 3 times maybe. They did do a lot of RS-25 testing, to be fair. They did an MPTA and a green run once. They did one green run on the space shuttle engine section. They loaded an external tank and the back of a space shuttle onto the B-2 test stand, just like with the core stage, and they fired it once. That's testing. That would be like testing a 747 using the same type of testing that you use to test a rocket. Not a good idea. Not smart. Once again, hindsight's a little bit of 2020, but the reason why they had to test it like that is because they skimped on it during development. But that's another story. Watch the RTLS. This gets pretty hardcore. Yeah, Victor, that's right. Anybody that knows a little bit about planes is watching these numbers and going, so the thing basically is flying like this, right? And it basically pitched the shuttle engines up and went like this. Now the shuttle's flying backwards with the external tank attached. And it's trying to go back to KSC. It's trying to basically do it, not an entry burn, but negate its velocity, negate its downrange velocity, and do basically what Falcon 9 does when it turns around. It pitches up just slightly to push the apogee higher so it has more flight time so it can get back. Shuttle's trying to do that right now. It is right now in the shuttle's ascent, if this was happening, they would be dumping fuel and firing the engines at the same time and firing the ohms. You need all the thrust you can, all the TWR that you possibly can to get this thing back. That's dangerous. Very dangerous. Venting hydrogen out the side while the engines are on. We all saw what happened with SN10 when it did something like that on the ground. Yeah, never mind while the rocket engines were firing. Very bad idea. Isn't that air starting RS-25s? No, they've been lit the entire time. So, pilots, watch these numbers. Oh, I guess they did shut them off. I'm wrong. Never mind. No, those should be firing. Why is it just using the ohms? Huh. Oh, it's simulating an engine failure. I'm an idiot. Stupid. In this particular scenario, they had all 3 engines fail. Now, I was working off the abort contingency if 1 engine fails. If 1 RS-25 goes out, 1 or actually 2 would be the... 1 goes out, you could try to get to ATO, or you could try to do a transatlantic crossing. If you have all 3 engines pop, so like what happened with SN11, hopefully it doesn't damage the orbiter when that happens. Yeah, this is a worst case scenario. Triple engine failure. They tested them, Supercraft. The RS-25's actually got a good amount of testing. But they tested them once as an integrated unit. That would be like doing 1 test flight with an airplane and then being like, nah, it's good. That's 1 test flight. I mean, technically the shuttle had 4 test flights. STS 1, 2, 3, and 4. I would contend to say that's still not enough. Why keep the ET if all 3 fail? They got to dump the fuel rig, and they don't want to dump the ET is only designed to be sepped with no fuel in it. Or little amounts of fuel. See, shuttle with the RTLS, especially with the ohms, you're basically screwed. Yeah, see, this simulated triple engine failure. Oh, God, this is a worst case scenario. So they tried RTLS, that didn't work, the engines failed completely. So what they did was it was boosting back, and then, yeah, watch, it'll dump the ET wings up like that, just like it would if it went into orbit. Fire the ohms. Watch the altitude. So this thing, yep, tank has a lower ballistic coefficient, so you'd have to get away from it because you'd fall faster than the external tank. Why? The shuttle weighs more than the external tank at this point, right? The external tank is a big empty tank. It's like a balloon, so it'll slow down faster. Watch the altitude go. The altimeter is falling very, very fast right here. So, like, once again, you got to remember, this thing it's doing S-turns to slow down. You don't want to dip into the atmosphere too much. Turns back towards KC in order to allow the crew to bail out as close to land as possible. Okay. Okay, no, that wasn't an S-turn. I was going to say. That's what an S-turn looks like, though, if it does an S-turn in the roll reversal. Well, they dumped the fuel. They dumped the fuel during the RTLS. They're dumping fuel and firing the engines. Because presumably to have the shuttle boost back, you don't need as big of a burn as you would need to go all the way into space. But, once again, this thing is sinking like a brick. Yeah, that's the other thing. Yeah, that's right. Once again, pilots don't take off with an airplane with the intention of bailing out, so they didn't do that with the shuttle. And once again, you know, you can sit here and say, well, God, man, that's so stupid. Why did they do all this? That's so stupid. Well, they were trying to change the game. They were trying to wean themselves off expendable rockets. And in order to wean yourself off expendable rockets, you need to take some risk. Yep. Yeah. So what they basically would have done is fly around here, have the crew goes out the top hatch, out the 2 windows up top, they pop them out, and the crew would jump out there. But yeah, it's death. RTLS is death. Yeah, death. That's basically a death sentence. I mean, even bailing out of the shuttle. You bail out of the top, what's stopping the rudder from hitting you in the face during egress? You're going to jump out and right into the ohm spots. It's not a good, it's death. It's a death sentence. So NASA after Challenger basically started thinking about the shuttle like a rocket again, and the only solution there was to build a new shuttle every time. And that's basically what they did. If you replace every single component in that engine that you even think needs to be replaced, you'll know it'll work the same way every time. That's why the shuttle got super expensive. I often say that the shuttle is a space truck. It's a semi-truck. So it's a truck carrying a trailer, the trailer being the payload bay, right? Do you go camping in a semi-truck? Nope. That's basically what they were doing. Eat yourself out the side and go sideways. Oh, sideways. Yeah, how are we going to do that? Well, the tile refurbishment process for the shuttle was insane. Same thing, Zero. Same problem. The tiles comes from skimping on development. They didn't have enough time to design those tiles. They didn't design them good enough. And that's not to say that the folks that worked on the tiles were bad engineers. Look what happens when you guys threw a lot of money at the problem for the Luna 1 mission in Kerbal. You guys gave me a lot of money and not a lot of time. That's bad for a program. That's really bad for a program. Look at what happened. I put the crew it's the exact same thing. I put the crew into architecture. I put Jeb, Bill, and Bob into mission architecture that was not tested and was not as well fleshed out, and I had tons of problems. I don't know, just do it. Okay. They'd go out the main hatch with the escape pole. I think that's another thing that they could do. Oh yeah, that's right. There's the pole. Yeah, I remember now. There's that pole, and they have to basically slide off the pole and go, what is it, underneath the wing, if I remember right? Yeah, there's that too. But I know that the shuttle has a spot for egress out the top windows. Here, I'll show you. Here we go. Take a look. Do you know the difference between a semi-truck and the shuttle? With the semi, you can detach from your trailer in case of an emergency. Yeah. Flash? What? Really? Screw you guys. Flash. What a joke. Alright, well, I could probably show you here. See these wires? 1, 2, 3, 4, 5, 6, 7. With wires that all connect into the windows. They could jump out the top windows if they needed to. But that's about as dumb as jumping out of an airplane while it's crashing. You know? With the engine right there. Not a good idea. The window hatches were holed over from the ejection seats in the first shuttle. Doesn't the ejection seat hatch need to be like right here, not right there, for the ejector to work correctly? Safer to go down with the ship? I mean, Rogue, how many times do you, in the event of a crazy scenario, like an abort scenario with an airplane, do you hear about the pilots bailing out? That never happens. I mean, look at Sully. Sully had double engine failure. He's basically flying a glider. He didn't bail out. You really don't have time to do this kind of stuff, guys. The pilots are best at the helm of the air, or at the yoke of the airplane, because the pilot is the best chance of a plane getting back down. You don't want to bail. The shuttle only ever had 2 ejector seats. Yeah, I know. It had 2 ejector seats, and the ejector seats were on STS 1, 2, 3, and 4, and then they took them out. Once again, the idea is that you don't really need them. And plus, the ejector seats are dead weight. Seriously, they're wasted mass after 40 seconds of flight. You're too high. You're going way too high, and you're going way too fast to eject. Ejecting will literally kill you. This makes me scared for humans on Starship. Well, Elon Musk, Jake, there's no way that hey, Phil, 47-month resub. There's no way that Elon Musk doesn't know this. If we're here, sitting here on this Twitch stream, and we all know a little bit about spaceflight, and we know about the last time someone tried to make a fully reusable launch vehicle, or at least mostly fully reusable, so the shuttle, if we were able to sit here and come to these conclusions, there is no way somebody that makes way more money than us at SpaceX that's close to Elon has not thought of this either, or Elon himself. There's no way. Elon's also said on Twitter that Starship is going to have, he said, hundreds of flights before they even think about putting somebody on board. Which is honestly what they needed to do with the shuttle. The shuttle needed way more testing. They did, what is it in total? 5 approach and landing flights, and then 4 test flights. Four test flights for something that I don't understand how 4 test flights is even remotely enough of a data set for an orbiter with engines that are designed to be used 55 times. The RS-25s and the SSMEs were designed, they were originally intended to be used 55 times, no refurb, which is an extremely tall order. But there's no way that 4 flights, one green run of the main propulsion testing article is nearly enough data to prove that it's reliable. There's no way. That's not how that works. Now, with SLS, in SLS's case, because of the lower frequency of launches, I mean, at the very most, if my dream scenario is that it launches 4 times a year. 1 green run is good enough to quantify the data. Sure, no problem. That's fine. Because the SLS also has a board, so it has a board capability because it has an Orion capsule on it instead of a shuttle on the side. So you're taking a little less risk. Not even double digits. Yeah, I know, Geese, and this is what I mean when I say don't skimp on development for anything. That's a really bad idea. They tried to do it with SLS, and then every time they said, hey, develop it for this much, people would come back and say, no, it's going to cost more than that because we've never built anything like this. You're asking us to hot rod a space shuttle into a Saturn V. Yeah, you're reusing parts. You should be able to do that for less. That's not really how that works. They tried to, and SLS ended up getting the funding more or less that it needed. I mean, once again, people will argue that, oh, it's too much. SLS got overfunded. They got more than requested, blah, 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 blah. There's a really good reason for that, guys. It's not just something as simple as, oh, well, it's just that they want more money. It's a jobs program, blah, blah, blah. I wish it was that simple. If life was that simple, I'd be a millionaire right now. Especially don't skimp cash on a boarding thing, on abort scenarios. Well, Nugget, once again, the idea is that you design a system that's reliable enough where you don't have to worry about it, like an airplane, right? We have to think of Starship more like an airplane, really. See. The shuttle was still a rocket. Say what you want. A very clever rocket, but still a rocket. No. No, Swishio. They wanted to do what Elon's doing with Starship with the space shuttle. The space shuttle, they wanted to operate it like an airplane. That's what they wanted to do. And I'll just go out on the limb and say it. Everybody says that the shuttle's bad design. I don't think it's a bad design. I think it's a great design. But if you mature up those SRBs, which we ended up maturing them with blood, that's good. Great. Did the SRBs have any problems post-1986? No, because they redesigned them. They redesigned them after you know, the data was telling them that they could malfunction, and they never had a problem with them ever again. They had a problem with an SRB nose cone detonating popping too early once that on STS-27. Once again, another teething problem. Pretty much after STS-27, there's nothing wrong with the SRBs. So STS-27 was in the early 90s. That means 20 years of the SRBs firing, no problems. STS-27, how many shuttle flights came after that? 110 missions after that, no problems with the SRBs ever. Starship has no abort system and it will never need it. Well, if we want to, just like NASA, what NASA was trying to do in the 70s, if we want to take spaceflight seriously, we need to start being able to take something that can reliably move into space, and certainly something that we're not tossing into the damn ocean. See what I'm talking about? See, this is what's kind of worrying. For the first round of funding, for the first fiscal year of funding for the Human Landing System program, NASA asked for like $1 billion and they got like $400 million. They got less than 50% of what they requested. Not good. Not good. And you're already seeing the deadline slip. We were supposed to have an HLS down select in February. Oops. We're already starting to see the problems here. Dude, I hope this, if they underfund it again for fiscal year 22, we're going to have some serious problems. Into the harbor. That's right. Shuttle was great for its time, not so much today. Nuggets, I actually think if we tried to make the exact same design today, it would be fine. Yeah, I'm serious. I don't think it'd be I don't think it'd be a problem. Really. With all the CFD testing that we could do with that thing, yeah, I don't think it'd be an issue. I mean, you guys got to remember, the shuttle was expensive to fly. You know how much? So, like, if we want to look at it like a commercial venture, right? You know how much it costs to put a shuttle stack out on the pad and launch it? 400 million? 500 million? 600 million if it's a really crazy mission, like a Hubble servicing mission? That's like to put the SRBs together, stack it, redo the shuttle, put everything on the mobile launcher, move it out to the pad, fuel it, astronauts in, fly it into space, do the mission, come back down and land. 400 to 600 million. Now keep in mind that's in 2011 money, so that's probably a little bit more nowadays, right? But with an inflation adjust, 400 to 600 million though is that's really not that bad. That's not bad at all. Like, the Air Force is paying SpaceX for a Falcon Heavy mission. They're paying him $300 million. I mean, keep in mind, some of that $300 million is to build out a new pad, if we want to look at it from both sides. But, once again, if you compare apples to apples right now, right? So price, you look at it on per launch basis, right? The shuttle costs, let's just say it costs $500 million to launch every time, okay? So that's $500 million, right, for a mission. That's the mean, so the average. Falcon 9, on the other hand, over here, what's the average on Falcon 9? And once again, I want to be very clear. I'm a huge SpaceX fan, so I'm not saying that SpaceX is bad. I think SpaceX is the way forward. I think Elon Musk will do what the shuttle was trying to do, and he'll succeed, for what it's worth. The shuttle can move 7 people into space, 8 if you absolutely have to, and 25 tons of cargo on top of that. So in one shuttle flight, you move 25 tons and 7 people to low Earth orbit, and then do with what you want. How many Falcon 9s is it going to take to do that? Well, one Falcon 9 can move 22,800 kilograms to low Earth orbit in the Block 5 configuration. It is a heavy lifter by definition. So you need one Falcon 9. What's the mean price for a Falcon 9? 60, 70 million, right? Falcon 9 varies depending on if you launch it with cargo or with crew. The crew prices are for a Dragon is about 100 million a pop. And these numbers may have changed, so feel free to just check them if you want to. It's 100 million to put crew on there, and that's 4 crew. So just to equal the shuttle's crew here, you need $200 million in 2 Dragon launches, okay? So we're up to 200 million. Now you need let's say another 60 million because Falcon 9 in its cargo configuration is 60. Say you're even using a reused booster, okay? So that's 40 million for a reused booster. That's what we heard the price is, right? So it's 240 million to do what the shuttle can do, right? And that's expending the cargo. That's expending the first stage on the cargo mission. 22,800 is if Falcon 9 operates in expendable mode with a Block 5, right? And these are the numbers right off of SpaceX's website, right? So that's 240 million. You expend a booster, right? If the booster's going to be expended, I assume that SpaceX, it would be a new booster, or even you could use a reused booster and expend it. So still say 240 million. So you have 500 million over here and 240. Now, once again, I'm not saying that, the shuttle is cheaper than SpaceX. It's definitely not. But it's not as bad as people think it is. So 240 million to do all that, right? Versus the one shuttle, which can do it all in one launch. Now, it's about double the price, right? However, the reason why the space shuttle costs so much more is that it does more. Simple as that. 60 million for a Starlink. Thought it was like 120 million. I'm scraping the bottom of the barrel, Reagan. If you want to go get the commercial crew prices per launch, they're out there. That's public record because it's a mission with NASA. I thought it was 100 million. I could be wrong. I know it's not below that. So what can the shuttle do? Well, the shuttle has down mass capability. It can resupply stations. You can build things on orbit with it. It can service satellites. That's where that 240 million extra comes in. It can take stuff up. It can bring stuff back down. It can build space stations that Dragon can get to, might I add. You could use it to build out lunar architecture. You could use it to go and you could use it to build a commercial space station. You could use aggregate payload space to launch commercial satellites, which is what they did until the 90s. There's a lot of stuff that you can do with it. It's a useful vehicle. You could even have the shuttle with an EDO pallet stay up there for 2 weeks if you need it on orbit for a long-term mission, or you could plug it into the station and have it stay up there for a little while and use the station power exactly like what they did. You have a very, very flexible capability with the space shuttle. Now, it really comes down to personal opinion if that extra capability is worth the 240 million. Some say it is, some say it isn't. I don't know. But the point that I'm trying to make is that the shuttle is not as expensive as people think it is, comparatively. But, once again, the capability to dollars thing here really comes down to opinion, I guess. I personally like the space shuttle, and I'm not hating on Falcon 9 by any means. You know why? Falcon 9 flies, the space shuttle doesn't. Any chance the shuttle will ever make some form of return even under a different vehicle? Unlikely. How much would it take to build a new orbiter in 2011? Clean sheet it, came here. Seriously, clean sheet the design. Start over. Start over. The other thing that NASA was planning on doing is that the orbiter chassis guys are rated for 100 flights. They never even got close. Discovery had the most with 39 missions, not even 50% on the airframe. NASA was, if they were going to launch, what is it? They were going to launch once a week. How many weeks? 52 weeks in a year? With 4 orbiters? That means in 4 years, 8 years, all the orbiters, you'd need replacement ones. So you'd have an orbiter assembly line. So now it'd be like airplanes. It'd be more like airplanes, less you'd need serial production of space shuttles. They never did serial production. All the shuttles were one-off builds. They were all a little bit different in one way or another from each other. Shuttle C would save those 240 million. Yeah, Vasya, if you wanted to launch Shuttle C, sure, absolutely. Vasya, that's why I think Glishko was a genius with making a vehicle that could launch a shuttle, but also with heavy lift capability out of the box. That's what makes Energia good. And that's where he got it right. They should have done that with the space shuttle from the start. But once again, that's not what the shuttle was intended to do. Opponents can argue that you launch all that capability just for one specific mission each time. Floating disc, can a semi-truck move with a half-empty trailer around, or do you have to fill the trailer up every time? you're making the most money if the trailer is full with the cargo that you're moving every time, right? Yeah, absolutely. That's why NASA in the 80s, guys, had a program called the Getaway Special. The shuttle could pop out a bunch of satellites. So like its main mission, say its main mission was a 5-ton payload. That's 20 extra tons of space inside of that payload bay. There's no way that 5-ton payload is taking up the entire payload bay. So the shuttle could launch with a bunch of satellites. And that's what it did. It launched all different types of satellites to GTO. All different types of stuff. Actually, you know what would be really good? The shuttle would be really good at building like a Starlink constellation. Yeah, it'd be really good at it. You could even go up there and bring Starlink satellites that have broken back down if you really wanted to. What did the shuttle cost per launch before the Challenger disaster? I don't know, Connor. I'd have to go crunch some numbers to figure that one out. But with spaceflight, just like any other commercial venture, the more you launch, the more the price goes down. This is how airlines are able to operate. Planes are expensive. You can go online and find the price of a 737. It's pretty expensive. To get that plane to operate, to make you money, it needs to be flying more than it needs to be on the ground. Anytime you have an airplane that's just sitting on the ground, it's costing you money, right? So the higher frequency of flights would make the price go down. What's the name of that new shuttle design with 2 shuttles stacked on top of each other? XS1 core, I think is what you're talking about. It's canceled now. That got canceled a couple of years ago. Hope I'm not coming off as antagonistic, just considering opposite viewpoints. Well, the orbiter weighs 80 tons and has a 20-ton payload. A semi-truck has a better ratio, I guess. I mean, physics is a pain in the butt. Interesting, right? Like, the shuttle is not that bad comparatively. It's not a bad low Earth orbit vehicle. It's not a bad design. Everybody harps on it because, for some reason, and once again, this is going to sound messed up. And I'm not in any way, shape, or form trying to undermine our brave explorers that go up into space. People get hurt on a spacecraft, it's a big deal. People get hurt on an airplane, no one cares. People get hurt on in a maritime accident, nobody cares. People get into a car crash, no one cares. But with spaceflight, though, it's big. Like, see what I'm talking about? Like that, it kind of sucks that, we look at it that way. But also, space is a little bit more complicated than driving your car around. And once again, that's what I mean. I'm not trying to undermine, the folks that have, died in the pursuit of, moving humanity to the next level. You shouldn't take their names in vain. That's not a good idea. But once again, that's just how we do things. Human's gonna human, man. Oh, Cora, I don't know. Rocket Guy showed it to me, and I was on my way out, so I didn't get the name of it. He only showed me pictures, and the pictures were just, yeah. Has there been any news on Dream Chaser? It's gonna fly early next year, Tom. They're working on the first Dream Chaser right now. SNC is working on it. You can check their Twitter, and they'll they have pictures of it. They have pictures of people putting it together. It's really cool. Depends on where the ship gets stuck. Is Dream Chaser by NASA? It's being contracted by NASA, Jack. Sierra Nevada Corporation, SNC for short, is the company that's operating it. They're using Dream Chaser to deliver supplies to the ISS. Speaking of the ISS, so this is coming from Roscosmos here. Oh, jeez, we're super late. I'm gonna plow through this news real quick, guys. Mission Control Center specialists adjusted the International Space Station on orbit in accordance with the station's flight program. Specialists are analyzing the telemetry data and defining the ISS orbital parameters. So they boosted the station again. The Zvezda module out back, or Progress, can boost the station. Roscosmos, because they have the propulsion element of the station, is really that's their domain. So they adjusted the orbit again. They basically boosted it. They recircularized it back at 400 kilometers. So this one's kind of interesting. In April 2021, 6 volunteers will take part in a ground experiment to simulate a flight to the moon in a spaceship, or Orelnak, or Little Bird, or Little Eagle, I guess, in the Oriole spacecraft. The experiment will last 2 weeks, and the crew will include 4 men and 2 women, all employees of Roscosmos. Knock, knock, Vinmus Denlied. Yeah, literally, I just said I got to get through this quick. So we're going over here. AMRO is a is a defense contractor, but they are also making parts for SLS. Right there is the SLS inner tank for Artemis 3. That's the inner tank for it right there. Notice the stringers. This will be covered in foam, and that's the hole for the SRB attachment point, and then the SRB beam, because the SLS core stage is derived from the shuttle. It's very similar structurally. It's not the same, but it's similar. There's the beam for the SRB attachment point. The horizontal beam will go through here. This is one of the aluminum plates. So this is milled aluminum. So they start with a block of aluminum that's as thick as these stringers, and then they mill it out, and then they put it through a brake to get it to... So the ISS is really a ship, not a space station. It's a spacecraft, Nuggets, for all intents and purposes. It's not stationary, that's for sure. After the shuttle program ended, Nuggets, the ISS was in like a 300-kilometer orbit. They had to boost the station all the freaking time, because the station had to stay at a low altitude so the shuttle could get to it with a usable payload. After the shuttle stopped flying, they boosted the station to 400 circular. It's actually flying 100 kilometers higher than it was when they built it. Yeah, it's a space. It's a spaceship, dude. It's just a spaceship that doesn't go very far. Oh, no problem for it. It's all good, man. Chat delayed, no big deal. So, I'm not sure. Thomas linked me this, but he's an astrophotographer, and he took a picture of something. Stand by for my publication in next week's image. I took a secret capsule re-entry vehicle that appears to be in space for 8 years already. Here's a sample. There's Gunter from Gunter's space page. That's cool. That almost kind of looks like what I saw, dude. Because the shuttle was only good for low Earth orbit. Nuggets, the shuttle could fly up to 400 kilometers circular. That's where the Hubble is. Hubble's actually just a little bit higher than that. But the thing is, it can't do that with a usable payload. When they went to service the Hubble Space Telescope, all they had was a toolbox in the payload bay and the mount for the Hubble, and that's it. So basically no payload inside. Misty, the second photo I linked, is a spy satellite that pulled a Zuma and failed, but was actually in orbit with a deployable mirror, so people on the ground couldn't see it until someone did many days later. If Ralph got a picture of Misty, that would be epic. Cool. I wonder what the new solar panels, why they didn't remove them. With the new solar panels, why they didn't remove... They'll probably retract them, Maslam. The solar panels they don't need to be removed. They can be retracted. So, the solar panel basically has a ring gear, a helical ring gear at the very bottom, and what it does is when the ring gear spins, it has like a telescopic truss segment in the center, right? And as the ring gear spins, the helical ring gear, it takes the truss segment and unfolds it, and that's what unfurls the entire solar panel. The solar panels are like a roll of paper towels. They just pull it open, but it's actually like a shade. So you pull the shade down. Solar panels are built like that. I bet you they might retract them when the new solar panels go up, or they might have all the solar panels working to be able to increase the power supply of the ISS. I think that's what they said they were going to do, but I'm not 100% sure. Okay. I'll save Neopork's diagrams for another day. So this is coming from Oleg Artemiev. He took a picture of Roscosmos workers at Gagarin's start right here, and that's the Russian word for "let's go." Poyekhali, which is what Yuri Gagarin said on April 12th, right after he launched. He said, "Let's go!" right after they launched him off the pad to go into space on the first space flight, April 12th, 1961. So that's pretty cool. They're going to launch MS-18 right around the same time, 60 years later. Pretty cool, huh? And the last image is a little bit painful to look at, but this is coming from Coop Heim, who is another guy out there taking pictures from Boca. Oof. Ugh. Ugh. So, okay, guys, just something interesting to look at here. This side of the Raptor engine is cooked. Something really hot hit the side of this thing. Comparatively to the bottom, which is not cooked, but broken because it impacted the ground, right? But look at this side of the Raptor. Everything is burned. Everything is burned and melted on this side, indicating a very, very high energy event happened somewhere along the line here. Yeah. Look, it was enough to bend a casting. Bend the casting on the methane impeller. Actually, I don't think that's the impeller. I think that's the turbine. The impeller's up there somewhere. Link? Got it. So, this could have been from the impact, but if you bend that casting, it either indicates, I mean, castings don't bend. They crack. Like concrete. That's just because of how metal gets, how metal turns out after you cast something. It's also the strongest, but also look at that. The casting either melted or it's bent, which is, casting breaks unless it gets very hot. Yeah, Dragon, you know how much heat you need to do that to a casting? See, it cracked right there. That's from heat, no doubt. The reason how I can tell it's from heat is because the crack is a different length, right? This looks like a break from stress. That's what castings do. They crack. See, it's cracked right there, but it's bent right there, indicating something really freaking hot happened right on this side of the engine. Like really hot. Once again, what happened with SN11 is a mystery. I have no idea. See down here, the preburner? I think that's the preburner. This shiny piece down here, see the top right there? It's cracked. The plumbing is cracked off. That's what castings do. They crack like concrete. That's cracked and bent. And then it's cracked over here. See that pipe? See the cracks? Cracks. Yeah, something really, really hot happened on this side. All the insulation is burned, all the pipes, all the plumbing is melted. All the metal is discolored right there. That's something crazy happened to this thing. Over 4,000 degrees to forge. Well, I don't know what that casting is made out of. I'm gonna guess Inconel, or an Inconel alloy. Well, Inconel is an alloy, but yeah, something really hot happened there. At least that's what I think. That's just a guess. I have no idea. I don't know. It looks like some kind of explosion. Car hit the wall at some speed. Took the top off. Severed her heads. You're an alloy, Akabidi. Got him. The GoPro footage from the forward flaps lasted even after it reached the ground. Really nervous? I mean, well, it seems like okay. Nervous. The nose cone, I noticed this when we looked at RGV's footage. I noticed the nose cone control surfaces were in the upright position. And you know what that tells me? That tells me that those wings were actuating all the way to the ground, even though the back half of Starship wasn't attached. I noticed that. I noticed it landed on its belly, and it landed with the wings in the upright position. The wings don't fold into the upright position until well into the landing burn. Look, right here. See? Watch them fold, right? There, see? Which means, okay, that kind of makes sense, which means that the nose cone had power all the way until it plowed into the ground. I talked about it the other day. I'm like, what? Dude, I can't, usually I can kind of extrapolate a guess to what happened. Like, we could see the green trails from SN8, so we knew what happened with the engine. SN9 had a failed relight. SN10, helium bubbles, from what Elon said. It hit the ground too hard, right? I have no clue. I have no clue what happened to 11, dude. I don't know. I can't even venture a guess. We didn't see it. I don't know what happened. Something happened. A big explosion. You think the nose cone was Flappy Birding until impact? Sure, Tessa. The wings are like this until about halfway through the landing burn. Halfway through the landing burn, then they fold right there. See? Watch. Whoop. And the wings on the nose cone, when it hit the ground, were folded up. So that means that must mean that thing had power all the way to the ground. Like this, right? Like, didn't they say they lost connection and had to trigger the flight termination system? Sebi, I have no idea. Yeah, I know, Ivo. I don't have enough evidence to tell you what happened. All these pictures and everything we've heard from all the sound and everything indicates some big freaking explosion. I still don't get why the CH-4 header is perfectly split in half. Dude, Thomas, I can't figure it out. I don't know what happened. Now, this is, hang on, this is part 117, I think. This is mission mode part 117. One thing that I'm kind of coming to the conclusion of is that, look, SN-15 is getting stacked right now, and they plan on moving it to the pad very soon. I don't know if it has engines in it. I'm sure somebody here does, right? So, SpaceX is basically just trying to keep going, right? Now, two things. First and foremost, is SN-11 had some kind of problem during Raptor relight. Does that necessarily mean there's a problem with the Raptor engine?